Welcome to Easy BTech. I'm Dr. Gayatri. I'm going to explain you about the characteristics of matter waves. In the last class, we have seen de Broglie's wavelength, which was given as lambda equal to h by mv. And we also expressed it as lambda equal to h by root of 2me, where capital E was representing you the kinetic energy. And we have also represented it as lambda equal to 12.26 by root capital V, where V was representing potential, the voltage, Armstrong units. So now using this equation, lambda equal to h by mp, we can draw the characteristics of matter waves. So here, if we look at lambda and m relation, lambda is inversely proportional to mass, which states that lighter the mass, greater the wavelength. Smaller the mass, greater the wavelength. If you look at for velocity, it is also inversely related. That is, smaller the velocity, greater the wavelength. Okay, and next we can have here velocity 0. When is it possible to have this situation? Only when the particle is at rest. If the particle is moving, certainly velocity will be there. You will not have this value to be equal to 0. Only when the particle is moving, you can have v is equal to some value. Otherwise, the particle is at rest position, which is giving you 0. In such a situation, what will be the wavelength? Wavelength is infinite. So what does it conclude? Wavelength is associated. That means wavelength will be existing only with moving particle. If the particle is not moving, there is no wavelength, which means that the particle is at rest. The next important point, we are not having this wavelength to be dependent on charge. So, irrespective of the charge and the present over there on the particle, matter wave will be existing with them. Irrespective, it is independent of the charge. Since you are having the wavelength to be independent of charge, irrespective of the charge that is present on the particle, matter wave is associated with it. This proves us that these waves are not electromagnetic, but they are a new kind of waves called as matter waves. So what am I saying here? These particles are irrespective of charge, independent of charge, I can say, independent or irrespective of charge on the particle, you have matter wave existing. Matter wave is existing. Matter wave is existing. So what is this concluding? These waves, these matter waves, these are a new sort of waves called as matter waves, but not electromagnetic waves. They are not electromagnetic waves. Next comes, we do not have any phenomena which will exhibit particle nature and wave nature at a moment, at the same time, simultaneously. For example, if velocity is 0, that means the particle is at rest position. You cannot give wavelength. If the particle is moving, can we locate its position? No, it's not at all possible. Position of a particle is confined for a particular location, and when the matter wave is associated, you are unable to locate that particle. And you are having wavelength to be associated only with a moving particle. This concludes here with your Heisenberg's uncertainty principle. So from your lambda equal to h by mv, we can also have Heisenberg's uncertainty principle. So next one is very important for us. That is velocity of matter waves is always greater than velocity of light. So to have this, we have a simple derivation, a very simple derivation. We know that according to Planck's law, E is given as h mu, and we also know that according to Einstein's relation, we have already done before, E is given as mc square. This is nothing but hc by lambda, and this is simply mc square. Now from these two expressions, h mu and mc square, I can have h mu equal to mc square, or I can say here that this could be written as hc by lambda, which gives me mc square. Okay. Now we know that velocity of a wave is given as, here since we are talking about matter waves, it is the velocity of matter wave is given as frequency into wavelength. Mu represents frequency into wavelength. So here if I use this h mu equal to mc square, my frequency value will be simply mc square by h. This implies frequency of matter waves is mc square by h into lambda. Or I can also have from here simply to be said here with your lambda written as h by mv, velocity of particle. So I have mc square by h into, instead of lambda, h by mv. So what will happen? It will be c square by v. We cannot have velocity of the particle to be greater than velocity of light wave. It is always a smaller value when compared with velocity of light. In such a case, what will happen? The velocity of matter wave will be greater than the velocity of light wave. V is your velocity of a particle. C represents velocity of light. So velocity of a particle is always less than that of light. Since this is happening, we have velocity of matter wave to be greater than velocity of light wave. This implies greater than light wave. This is the last conclusion and a very important for your short answer. Even in your internal exams, generally this question comes under objective. Velocity of matter wave is dash than light wave, greater than or less than. It is greater than. So these are the characteristics of matter waves. Thanks for watching. Like, share and subscribe to Easy BTech.